In this video, we're just going to finish up with how to draw Bohr models, and we'll do a couple of examples. In the previous video, I mentioned that the first shell can hold a maximum of 2 electrons, and that's just because that first shell, or energy level, is small, and the electrons, they repel each other. So they want to be close to the nucleus, if they could want to do anything, but they repel each other, and so maximum 2. The second shell is a little bit larger, and it can hold a maximum of 8 electrons. Now you're going to learn more about why this is if you take Chemistry 11. The third shell for what we're doing also holds a maximum of 8 electrons. Now I don't want to confuse you, but I don't want to give you incomplete or wrong information either. The third shell technically can hold 18 electrons. However, we start to fill up the fourth shell, and then we go back and fill up the third shell to 18. And that's not going to affect you this year because we're only drawing Bohr models for atoms smaller than calcium. Calcium is atomic number 20. Okay, so for our purposes, it would be 2 in the first shell, 8 in the second shell, 8 in the third shell, and if you have any more to draw, you can put them in the fourth shell. Let's do an example. We'll do chlorine 35. Okay, so we earlier identified chlorine 35. If we write the standard atomic notation, we know it's going to have 17 protons because it's atomic number 17. If its mass number is 35, it must have 18 neutrons. So that's our nucleus. This represents the first shell, which can hold 2 electrons. Now I have 17 electrons to draw total. This is a neutral atom, which means that the number of protons, 17, equals the number of electrons. So I've drawn 2. The next shell can hold 8. 4, 5, 6, 7, 8. Now notice the way I draw them. I space them out until I have 4, and then I start to pair them up. It's a good practice to get into, and you'll figure out why later when we start talking about bonding. I've drawn 10 electrons. I have 7 more to draw. 3, 4, 5, 6, 7. Okay, so I'm 1 short of being full in that last shell. Okay, that's it. That's my Bohr model for chlorine 35. Let's do one more. We'll do hydrogen 2, also called deuterium. And I've chosen this one just because it's kind of interesting to note that hydrogen has several isotopes. This is hydrogen 2, meaning mass number 2. Hydrogen is always atomic number 1, meaning it has 1 proton. If its mass number is 2, that means it's going to have 1 neutron to add up to 2, and 1 electron. So that's it for hydrogen 2. We'll do one more. We'll do carbon. Notice it just says carbon. It doesn't tell you which isotope of carbon. If you look on your periodic table, you'll see that carbon has an average atomic mass of 12.01. So we're just going to round it to 12. That would be the most common isotope of carbon. So carbon 12 would look like that. So 6 protons. If the mass number is 12, it must have 6 neutrons. And I've got 6 electrons to draw, right? Same as my number of protons. 2 electrons in my first shell. I've got 4 more to draw, and they can all go in the next shell. So that's it, and then we'll do some more practice in class.